Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 169, count subarrays with majority element 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So first of all, I actually looked at a lot of solutions afterwards and people did not do it my way. A lot of people did it with this thing called binary index tree. And I'm not going to go over that solution. I don't think it's that difficult, but I don't know. I mean, I don't want to go over every solution, so I have to choose. But this is the solution that I chose, and I think, honestly, it's easy to understand because, well, you do not need binary index tree. So that already makes it easier to understand, kind of, maybe. Let me know in the comments if you disagree. But all you need is balanced binary index tree, even though I use a sorted list, and prefix sum. For this one, I am going to slow it down a little bit and go over some ideas of prefix sum, right? I think the first thing that I would recommend people do if they, either before or after listening to the explanation, you could pause right now and just do one of the prefix sum problems on like subarray sum, like count the number of subarray sum is equal to 0. Something like that. If you Google that or whatever, ask ChatGPT, I don't know. If you, it shows up in Leetcode like 2 or 3 times, maybe even more, just by itself, and embedded in harder problems more times as well. But like this count subarray sum is equal to 0. If you find that, that is the, I wouldn't say it's a prerequisite because I'm going to go over a little bit, but I recommend you solve that first and then come back, and then it'll make this problem a lot easier. At least, well, a lot easier. Maybe it's not easy enough, but in any case, right? So do that. And then afterwards, yeah, I'm going to do some drawing. And the idea here is prefix sum. Alright, let's always assume that you already understand what prefix sum does, right? Then the idea behind this particular problem is that, well, let's convert target, right? So that means that every time you have a target number, it's going to be a +1. And then every time you don't have a target number, it's going to be -1, right? And this idea actually comes up a lot as well. There's like, I said subarray sum is equal to 0, but there are other variation of this where it's not subarray sum, but like you only have zeros and ones. You have count the number of subarrays in which you have the same number of zeros and same number of ones, or something like that, right? So there are a couple of variations on that problem as well on Leetcode. So find those and work on it. But once you do that, then this transformation should be easy to understand, which means that and you could do it either way, but anytime you have a target, you +1, and then when you have anything else, you have, well, just -1, right? And then now, so what that means is that then now your array now looks like this, right? Maybe something like that. And maybe I'll just, instead of adding the ones, I'll just make it a little bit easier to write. Just write, just plus and minus, right? And then the idea here now, then, right, is that, okay, we have a prefix sum. And the same idea, which is, and I'm going to do this part a little fast because, like I said, do the other problems, right? Is that, well, let's say, this component has 3, this component, I misdrew, has 3 pluses and 3 things, right? But, so this is a thing that met the other problem that we were saying. And if you can look at the prefix sum, you start with, a no element, right? So this is 1, 0, 1, 0, 1, 2, 1, 0, -1, 0, -1, -2, right? And then the idea here is that if you have a prefix sum, to look up, to kind of, find where these zero sum things are, well, in a prefix sum kind of way, we have this number, right, which is this number, and then we have this number, which is this number here. So, and of course, in a prefix sum, if you take this number and you subtract by this number, then, or this segment minus this segment, you get this segment, right? And that's just prefix sum stuff. So then it's equal to this part, you subtract out here, and then you have this part left remaining, right? Okay. And then the idea is that, okay, well, how many zeros or how many solutions are there where this is 0? Well, then now, and we could assign variables to do these things, right? Oops. Let's just call them basic things like A, B, and C, right? So here we know that we're looking for A minus C is equal to B, right? We know what we want B to be equal to, right? We said this. We said B is equal to 0. And it's 0 because that's what we're looking for. A, we already know because of this variable, but of course, it doesn't matter where you are, right? But it's just that we know it, right? So it could be here for this current A, but let's say you want to look for here, then it's going to be this one because this one matches this one, but because A is equal to 1. So you have A, which we know, minus C, which we do not, is equal to 0, which is what we're looking for. And of course, you could do maths on like add C on both sides, so then A is equal to C, which is how I know that when I have this number is 0, I just have to look for the previous zeros, 1, 2, and 3. That means that we have 3 times, right? That means that we have 3 subarray, which is this one. We have 3 pluses, 3 minuses, this one, and this one, right? And so forth. And if you're at -1, for example, here, then you see it appear once. And of course, looking these things up, you just use a frequency table or something like that, right? Okay. So far I've described nothing new or nothing. I mean, it's a build up to this problem, but not this problem, right? Because for this problem, you want the majority, not this 0 thing, right? So then what does this mean? Let me write it. I guess I'm gonna. Well, majority. What does majority means? Majority means that we have more pluses than minus, right? That means that, maybe in another way, we have A minus C is equal to B. Well, okay, maybe I lied. We have A minus C, right? And to figure out some segment B. I guess maybe I could write it that way, right? But B now has to be less than or equal to 0, right? If it did I write? No, sorry, I can. Is it less than signs are tough, sorry. Well, we're trying to find a case in which B is greater than 0, right? Sorry, I got the sign messed up, right? Because if B is 0 or B is greater than 0, it means that well, not this. This is not a good one. Actually, I guess starting from here, there's just no majority, other than one array. But if B is greater than 0 because it means that what is B? Again, B is a subarray, and it doesn't have to end up in here. It's just like a representation, right? It means that within this subarray, there are more pluses than minuses, and there are more pluses than minuses, then B is greater than 0. So that means that we have A minus C is greater than 0, right? And that's it. So then now we have to search for, and again, you just do basic algebra, you add C on both sides, you have A is greater than C, right? And that's it for this one. That means that now, if we, for example, in the prefix sum, and we know what A is, we just have to find the other ones, right? We have to find not the other ones, but the count of the other ones. So that means that if we're at here, again, let's just say 0, then we just count the number of numbers that are, well, smaller than 0. In this case, there's 1, -1, right? Let's say we are here instead this time, then we have to find the number of number of C's where they are smaller than 1, which is there's 1 here, and 1 here. And of course, you can even double check your math. This is of course the 2 pluses. and the same thing here. And that's basically it. And then now you nailed it down to, okay, you converted the problem to, okay, you have a prefix sum. You're trying to find the previous prefix sum in which it is less than the current number, right? So you're given A, you're given C, so then now you just need a data structure to support it. And I already gave it away a little bit in the beginning, which is the binary, balanced binary index tree, but you could also use the sorted list or maybe other things if you really like, but that is basically the idea. And you can also still use segment tree and something like that to kind of get the sum of a prefix, right? But that's basically what I did. Because why did I use the sorted list? Actually, let me go back to, because the reason why I use the sorted list is that now I can. The reason why I use the sorted list is because the actual, given a prefix sum, let's say we have a prefix sum of 0, 0, 0. I mean, not in order because we sorted them. This is the sorted list. And let's say now we have a number that's 2. Then all we have to do is just do a binary search to count the number of numbers less than 2. That's why I use the sorted list. Pretty basic. And yeah, so now I have a sorted list. I have current, that's the current prefix sum, right? We enter the empty set, the no set, right? We set, this is the number of count that we return. Okay, if x is equal to target, we increment by 1. If else, we subtract by 1. This is the prefix sum conversion that we talked about. And then after that, we do a binary search, right, on finding how many numbers are small, how many prefix sum, more specifically, are smaller than the current number on the things, on the visualization that we talked about. We add, and we add it to the sum, and then we just add the current prefix sum into the sorted list so that it can be searched for later in the future. And that's it. That's all I have for this one. Let me know what you think. Oh, let me go over the complex. I forgot. Sorry. Because of this sorted list, I mean, this is O of n number of iterations. Because each iteration does log n moves. So this is going to be n log n time, O of n space. And that's it. That's all I have for this one. As you can see, this is, once you have all the background and practice and infrastructure set up, I was able to do this in 4 minutes or so, and I even had a typo, so that took a minute or whatever it is. So Ash, pretty okay, right? Let me know in the comments what you think. Of course, like I said, there is a lot of background to make it into this, as you saw. So yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve live in the contest now. Well, cheaters got it very quickly, so we'll see. Alright, Q4. That was a mess, right? Alright, you're given an injury. Oh, this is Q2, I forgot. Okay. So, sub-array in which it is the biggest. Man, that Q3 took me out a little bit, and I forgot about this. Okay. Anyway, because I misread it. How did I get 3? I only got 2 wrong answers. Okay. Well, and one of the wrong answers was not avoidable. I mean, if it was avoidable if you read it correctly, but I did not read it correctly. Okay. So how did I do this one? Pre-process as 0 and 1. And then we just count the number of things, right? So maybe that's not so bad, right? Because we don't really care about anything else, right? So, okay. So what does that mean? All right. Yeah, okay. Yeah, okay. Yeah, okay. Okay, yeah, no, I mean, this should be okay, I think. Maybe. It's just prefix sum, right? Okay, yeah. Yeah, okay. Yeah, whatever, I just... Okay, and then now we do a prefix sum, right? So I guess I didn't really need it that way, but fine. Okay, and then now we want to, what am I doing? We want to count the, no, is it bigger or greater than? No, it's this. Okay, for example, if it's a 1, then what happens? We want all the sub counts in which is less than, right? Okay, so maybe maybe I don't need this. Maybe this is a little bit confusing. Just rewrite it. Maybe rewrites can be later. I don't know. And then now we want to say, let's just have a sorted list, so that I can do the question much easier. Of SL bisect left. I think that's it, right? Something like that. If I can type correctly. And if I didn't mess up on Q3, this would have been pretty nice, maybe. Why didn't make me do the 460? Okay, so that's not right. How am I doing it wrong? So here we are at 2. I mean, it seems like I'm just missing it off by 1 somewhere. Right, so okay, at the first one, oh, I didn't add the 0, that's why. Okay, yeah, I mean, this feels kind of right. I was actually kind of confused that I didn't get it right. But yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm, today's contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye. Have to find the button.